So if you had been in class, you would have been able to participate in this amazing warm-up where we passed the pen and each student did one step in this wonderful long division problem. And believe me, it's long because look at the polynomial that you're dividing into. Okay, it's itself is a big polynomial. But I want to still do this problem because, well, we're going to use it as a sort of a springboard into today's lesson. So you can watch, you can pass the pen to yourself, but let's do this division problem. And the first thing I want to notice is that we're missing x cubed. Okay, so I got to put a 0x cubed in there. And then I realize I'm missing the, I guess I'm not missing anything else. I thought we were missing another x, but I've got all the exponents all the way down to the 4. Okay, let's pump this out because really what I want to do is I want to use this, again, as a springboard into today's lesson. So we're going to use 8x to the third. Of course, we're going to subtract. That means you change the sign. So now we have positive 8x cubed, bring down the 6x squared. Start over, look at your x, look at your 8x, and I hope that you choose 8x squared so that when you multiply, don't forget you're multiplying onto both these. That gives you 8x cubed and minus 8x squared. Of course, we're going to subtract, so that means, again, you got to change that sign carefully right there. That actually, I think now we're looking at 14x squared. Bring down the negative 2x up above. Look at your x, look at your 14x squared. Looks like I'm going to need a 14x, so that when you multiply, we also are going to subtract. So now I think I'm going to get a 12. Kind of running out of colors here. We'll go back to the red, bring down the 4. Please put a 12 up here so that when you multiply, you get 12x. And when you subtract, that is, change the signs, we're going to get 16. I'll just squeeze that down there as the remainder of 16. Very colorful looking problem, and also very long. You're going to be glad to know that there is a faster way. Yes, there's a faster way. It's kind of a way that bypasses all the x's. It's kind of a way that uses just the numbers. I'm talking about the numbers that are represented in both of these polynomials. And let me introduce you to what's called synthetic division. Now, when I look at the red x minus 1, what I really want to see is the number that makes x minus 1 equals 0. What do I mean, the number that makes x minus 1 equals 0? Well, it's going to be like the opposite number. In this case, it's the number 1. So not negative 1, but 1. What I'm going to do is put that 1 up here in like the corner with a little sort of corner bracket around it. Next, I'm going to look at the numbers, that is the coefficients that are represented by this bigger polynomial. But there's a missing coefficient here. It's a coefficient of 0. So each of these coefficients, that is 8, 0, 6, negative 2, and 4, also they get recorded, and the process of synthetic division begins. Now, before I do this, I just want to make sure you understand the red number that I chose is the number that actually makes x minus 1 equals 0. And how do I make x minus 1 equals 0? By using x equals 1. And then these gold numbers that I chose, these are just the coefficients. They're the coefficients of each of my x's and also that number 4. And so I list these numbers. I drew a horizontal line, which you'll learn helps to organize the synthetic division. Now what I'm going to do is I'm going to bring down that first number, and I'm going to multiply whatever number I have in this spot times that 1 up in the corner. And when you multiply those, you get 8. After I multiply them, I'm going to add the numbers in this next sort of column. And when I add them, I get 8. We're going to multiply again times the number 1, and you get 8. You're going to add in this column, and now I get 14. You're starting to see what numbers we're getting here. Okay, so I'm going to multiply it and get 14. I'm going to add and get 12. Multiply one more time and get 12, and add and get 16. Now, these numbers that we found, that is 8, 8, 14, 12, and 16, do they look familiar? Do they look like the numbers that we found up in our dividend? They are exactly those numbers. But what we want to realize is that the 8, 8, 14, and 12 are actually the coefficients of what's called a depressed polynomial. Now, a depressed polynomial is a polynomial that has an exponent that is 1 less than what we started with. You see, we started with x to the 4th, but now when I divide, I get x to the 3rd. So I'm going to take the number 8, and I'm going to put it in front of a depressed polynomial. That is, I'm going to put it in front of x cubed. We'll continue to kind of work down the line here. We'll put 8 in front of x squared. We'll put 14 in front of x, and 12 becomes my constant. This 16, of course, is my remainder. And just like that, I end up with the same answer. Again, I end up with 8x cubed plus 8x squared plus 14x plus 12 with a remainder of 16. And that was done with synthetic division. Now, synthetic division is honestly a much faster way to deal with polynomial division. Instead of using long division, we're going to use synthetic division, where we just end up using the numbers. We call them the coefficients here of each term. And then we also have to use the root. I called it the number that made the equation equal 0. It's the same thing, and we place that in the corner. And then you just use this multiply, add technique. Multiply, add. And so you end up with a remainder so that you can take your numbers that you got and use them as a depressed polynomial. Use them as the coefficients of a depressed polynomial. Think we can do it for x to the 4th minus 3x cubed minus 7x minus 14? Well, I bet we can. We just have to remember the process here. So first thing I want to do is I want to think of the root. That is the number that makes this equal 0. Is it going to be negative 4? It sure is. And I'm going to put that number up here in the corner. And then I'm going to want to look at my dividend, and I'm going to grab the coefficients from that. The coefficients are the numbers that are in front of each of these x's. Did you catch that there's an x squared that's missing? So we will be careful to use 1, negative 3, 0, negative 7, and 14. Negative 14. We want to make sure we use the negative sign that went with that 14. Draw a nice horizontal line, bring down your first coefficient, and the process begins. The process is to multiply and then add. And then you'll do it again. You'll multiply. Now, negative 7 times negative 4 is positive 28. We end up with kind of a big number there. But we multiply, and then we want to add these together. That will give us a 2. Multiply again, get negative 8. Add to get negative 15. Multiply one more time and get positive 60. And add, and you end up with 46. Now, what you want to realize is that these numbers that we found, that is 1, negative 7, 2, and negative 15, those are actually the coefficients of a depressed polynomial. My polynomial started with x to the 4th. That means my depressed polynomial is 1x lower, 1 exponent lower. It's going to be an x to the 3rd. 1x to the 3rd specifically, and then we can continue down the line with a negative 7x squared, with a 2x, and a minus 15. We do have this remainder of 46. This is my division problem brought to you by synthetic division. I bet you're ready to try one. You should. See if you can take 6x squared minus 5x minus 6 and divide it by x plus 3. Go ahead, see if you can do it. Make sure you start with the root. Grab your coefficients. This one isn't missing any values, so my coefficients are just 6, negative 5, and negative 6. Bring down your 6, start the little process by multiplying. Add these carefully to be negative 23. Multiply them here to be 69. And add one more time. We should end up with 63. Now, my last number always ends up being the remainder. As you guys will realize, that's because if I started with an x squared, then my depressed polynomial is already down to an x, a 6x because of my coefficient. And then, of course, the 23, the negative 23, is my constant value. So, yeah, 63 ends up being the remainder. The last number is always the remainder of the problem. Pretty nice, eh? Well, here, let's learn something else. Let's kind of add something else to this concept. What we want to do is we want to now plug in. We want to kind of evaluate P of 3. Now, if you're saying, what do you mean P of 3? Well, first of all, P of x is my 6x squared minus 5x minus 6. It's my polynomial. So it's the polynomial that I'm dividing into. Again, we call that a dividend. I just want you to see what happens when you do P of negative 3, when you plug in negative 3. Okay, yeah, I'm just talking about plugging in like this, something we did a few weeks ago, or perhaps maybe more like a few months ago, and we were plugging in with like a parabola. But yeah, a little order of operations here. Negative 3 squared is 9. Negative 5 and negative 3 is positive 15. Of course, 6 times 9 gives you 54 plus 15 minus 6. Are you doing that math? Well, if you are, you end up with 63. Wait a minute, 63. I feel like I've seen that before. That's right, it was the remainder of my division problem. Well, that's not coincidence. In fact, it turns out that plugging in negative 3, that is doing substitution, will be the same as getting the remainder from the division. Let's see if that's written underneath here. So the remainder is the same as the value of P of 3. The remainder, that is the 63 that I got, is the same as the value of plugging in negative 3. And what we actually have here is kind of like a interesting way to do a little bit of some substitution, some plugging in. We call it synthetic substitution. Now, if I want to use synthetic substitution to actually evaluate P of 4, do you realize that that means I'm going to need to divide by 4? I'm going to divide by 4, not negative 4. You see, the number that you're plugging in, well, has to be the same as the number that went up here in the corner. I should have pointed that out in this example. So let's make sure we understand that the number that's up in the corner, not the opposite of the number, but the number up in the corner is the same as the number that I'm plugging in. So what that means is if I want to do synthetic substitution for P of 4, then I want to be plugging in 4. Straight up plugging in 4. You want to grab your coefficients. Okay, your coefficients, just like we've done in the last few problems. Now we are missing a coefficient of 0. We'll make sure we put that placeholder in. A little bit of synthetic division, but what I'm actually doing here is a kind of alternative to doing substitution. So when I plug in 4, when I evaluate 4, I can do that by actually dividing by 4, and I end up with 179. Do you realize that 179 ends up being the same value? It ends up being the same value as if I had plugged in. P of 4. Now, do you trust it, or do you kind of need to check it? If we plug in P of 4, if we kind of do this sort of the old way, then I'm going to end up cubing the number 4. I'm going to end up squaring the number 4. Also, some of the other calculations that are part of this. And, well, do you need to see it? Do you believe it? 4 cubed is actually 64, and 64 times 4 is going to be 256, kind of a big old number there. 4 squared is 16. 16 times 5 is 80. And then if you add 3 more to that, yep, you end up with 179. So synthetic substitution. Okay, all I really have to do is just divide by the number that I'm plugging in. So, we come to the end of the lesson again. If you were in class, I would be asking you to try this little exit problem. You still want to try it. Make sure you pause the video at this time and see if you can perform these 2 problems. Yes, I will go over it, but you want to pause the video, check and see if you have the right learning. Now there's 2 missing coefficients, aren't there? We're missing an x and we're missing a regular number. Both those need to be filled in with zeros. You always want to work yourself down to the bottom, to basically the number. $60 times 5, that should be 300, right? Let's just double check that. Yep, positive 300. It ends up being my remainder. Now remember, your answer is not just these numbers. Your answer is the depressed polynomial. This polynomial started to the 4th power. Since it started to the 4th power, my depressed polynomial is going to be to the 3rd power. Of course, 1x to the 3rd power. So I get 1x cubed minus 2x squared plus 12x minus 60. Second problem. We want to evaluate, we want to find p of negative 1. But I'd like you to do that using synthetic division. So all I have to do is just divide by negative 1. I just have to divide by the same number. Do your regular synthetic division. Make sure that you multiply and add. And do you recognize what 4 represents? It represents p of negative 1. In other words, plugging in negative 1. Well, there's a half-sheet homework that you can find either on the calendar or back in the tray, a chance to practice some of this wonderful synthetic division.